previous video we learned measures of skewness. What are the types we have seen, and now this is the problem for related the Karl Pearson skewness. See, Karl Pearson skewness has two formulas. One has to be that mean minus mode by standard deviation, and another one is mean minus 3 into mean minus median by standard deviation. So this is the two formulas. Now we see the problem. We are going to find that this one mean minus mode by I am going to use this formula, mean minus mode by standard deviation. First, see the problem. So what is the data is this? This is the data for the continuous one. So it has what are the table columns we need for calculating the mean. Mean has class, frequency and mean values and D, FD. The 5 table columns we need for the mean, and mode as class and frequency is enough for that. The standard deviation and extra one more column we are going to find that FD square. So write the class as it is, class, frequency and then bit values. Next, D equal to x minus a by c, d square, fd square. So these are the tabular columns we need to calculate the Karl Pearson coefficient of skewness for the first formula. This is 50 to 60. The relating frequency is 12. 60 to 70. 70 to 80. The relating frequency is 25. 80 to 90. The relating frequency is 20. Next 90 to 100. The relating the values the frequency is 16. Next 100 to 110. The value is to be 10. Now the bit values we know where these 2 as add and divided by that 2, 12 is 10. So average of these 2 is 110 divided by 2, 55 is that bit value, next 65, obviously the next one is 75 and then 85, 95, 105. So clear. Next, in this series we are assigning x here. So, and we are going to find that a means we easily find out the d. So assign the a value in the middlest values for the mid values. Middlest value of the mid value is nothing but 75 and 85. So I choose the 75 as that a. So a has to be here I assign 75. Next x minus a means this is 55 minus 75 is minus 20 divided by the width of the class is c is nothing but 10. So size of the class is 10, so that minus 20 divided by 10 is minus 2, next that minus 1, 0, 1, 2, 3. See, next d square is make a square of this. Now we have d is, first one is 4, minus 2 square, there has to be 4, 1, 0 and then 1, 4, 9. Next fd. So we have a d and we have here. So multiply these two is minus 24. Minus 117 is minus 17, 0 into 25 is 0, 20 into 1 is 20, 16 into 2 is 32, next 10 into 3 is 30, next add of the positive value and the negative value. If we add that positive value of this is 62 and then 82 as that positive value, next the negative value is to be 141. So if you subtract, we get 41. So the value is to be this as 41. Next, fd square. So d square is here, f is here. 4 into 12 is 48. Next 17 into 1 is 17. This has 0. 20 into 1 is 20. 16 into 4 is 64. 10 into 9 is 90. And sum of this is 4, 7, 11, 11, 19. And keep 1 here, 5, 6, 8, 8, 6, 14, 20. And sum of the frequencies, 7, 9, 14, 6, 20, 2, 4, 6, 8, 10, 100. So the capital N value is here 100. Capital N equal to 100. Next, first find mean. Mean is nothing but x bar equal to a plus summation fd by n into c. This is for the continuous formula. So what is an a value we are assigning here? 75. So write that 75 plus summation fd is 41 divided by n is 100 into c is 10. So 1 0 1 0 cancel. 75 plus this is 41 divided by n is 4.1. So the 79 point, this is the mean value. Okay, next we are going to find that. Next to find that mode equal to, the formula is L plus F1 minus F0 divides 2F1 minus F0 plus F2. This is for continuous series into C. So L value is here. We have what is the highest frequency series? The highest frequency mark has to be the F1. The pre-model, the pre-value of the F1 is to be F0, and the post value of that frequency is to be as F2. F1 post value F2, F1 the previous value is to be F0. The corresponding value of the highest frequency has to be the lower classes, the lower limit. So here L is to be, L is here 17 and F1 is 25 and F0 is 17, F2 is 20 and C is nothing but 10. So already we noted down. So next, mode equal to, which implies L value is to be 70 plus F1 is 25 minus 17 divided by 2 into F1. F1 is 25 minus 17 plus 20. F0 plus F2 into C is 10. So this implies 70 plus 25 minus 17 is 8. This is 50 minus 37 into 10. C, which implies 70 plus 80 by, and 50 minus 37 is 13. So 50 by 13 is 3.85. So 70 plus 3.85. This is nothing but 73.85. This is an mode. Now the remaining standard deviation. So standard deviation is nothing but standard deviation sigma equal to square root of summation of d square by n minus summation of d by n to the whole square into c, which implies, so fd square is summation fd square value is summation fd square value stop. Next substitute the values of that summation fd square is equal to 239 divided by 100 minus summation of d 41 divided by 100 to the whole square into 10. 239 divided by 100 means the square root of this as 2.39. So 2.39 minus fd by is 0.41 to the whole square into 100. So this is nothing but the square root of 2.39. 41 into 41 is, so 0 minus 0.1681 into 2. So 2.39 minus 0.1681 is 2.22. That square root means 1.4901 is 1. So 49 into 10. This is nothing but multiplying 14.9. So this is standard deviation. Next, Karl Pearson coefficient of skewness. Karl Pearson's coefficient of skewness is nothing but mean minus mode by standard deviation. So mean value is to be 79.1 minus 73.85 for the mode. Standard deviation is 14.9. Next, 79.1 minus 73.85. The value is to be 5.25. So this is 5.25 by 14.9. By 14.9 is 0.3523. So 2 decimal is enough, so 0.35 is there. So Mr. of skew, Karl Pearson skewness is 0.35. This is positive, it is skewed. So ranges is, each and every problem's ranges is minus 1 less than or equal to or less than or equal to, so it's our skewness less than or equal to 1. The ranges is plus or minus 1. But the skewness, subscription is ranges. Thank you, students.